Welcome everyone to CS50 week 7 on SQL or SQL. This week we're learning a new language and going to be diving into relational databases and working with databases and building your own. So I'm Kelly, if you're new here. I'm the preceptor here at Harvard, and that's my email. And to begin with today, first I want to go into just some of the principles of SQL and what it means to create a database before we get into the syntax of how you actually write one. And so SQL is a really good example of how computer science is all about people, right? We're going to be storing a lot of information about people, places, events, things like that. And so how we manage this data, how we store it, is a decision that us computer scientists have to make, and that's going to make a big difference of how people use your data, how they collect and store that data. And so these are all things that you can keep in mind while you're working with databases, and it's a very real world thing that you'll see in everyday life. So typically with databases, you can think of this as like the timeline of how data is used. And so when it comes to collection, you can think about who are we getting data from and how are we getting that data, and then how are we storing it in a database like in SQL, and then how are people going to be using it. And so all of these things are good things to keep in mind while you're creating your database, because the decisions that you make are going to influence how you collect and how people use your data. So as maybe a prompting question, I invite you to think about how can database design choices actually impact the people that are behind the data, who are using the data, or who we're collecting data from. Feel free to put your thoughts in the chat, and I'd love to hear some of your thoughts on this. Some initial things that come to mind, at least for me, I think, it's with collection, who are we getting data from? How are we representing that data? We think about, like, in what ways are the ways that we're representing data? How might we be excluding certain people? I think choices like that are very real and very important to think about. Okay, well, feel free to put any thoughts if you have them, but we'll move on for now. So some quick design principles when you're actually creating a table that we want to build off of are, the first thing we should note is each table should be a collection of a single entity. For example, we should have a different table for each of employees and employee relationships. So in this example, employees should be a table of its own, and that should be separate from employee relationships, which we can call or think of as a separate entity. So if we imagine this, maybe I have a database of the staff who are working with me, and we have a table called employees that contains everyone's name and their role, and then maybe we have a employee relationships table that keeps track of the relationships between employees. So in this case, we have Laura is a manager of Alice, who's an employee. Another thing that we should keep in mind is that each piece of data should be stored in a single location and thereafter referred to via its ID, aka primary key. So in this situation, we should ensure that every employee has an ID and then use those IDs in the employee relationships table. So in this previous example, it's it could be possible that multiple employees have the name Alice or Laura. And so it's important to actually give IDs to each of these pieces of information so that Alice can thereafter be referred to as the employee with ID 1, which is separate from perhaps another person named Alice will have a different ID. And so this makes it a little bit more accurate when we're trying to represent things like employee relationships. So here, we can actually use that ID, which we're also calling a primary key, in manager ID and employee ID to represent which employees have this relationship with each other. Any initial questions on creating a database and these principles that we should think about when designing a database? All right, okay. So let's get started with actually designing a database of our own. So let's go with an example here. We're going to make a database called friends.db, and I'm going to hopefully keep track of some of the friends I have, some information about them. So I'm actually going to head over here to CS50.dev. I'm going to full screen my terminal, and we use the command SQL 3, which is a lighter version of the language SQL that we're going to be using, and then just the name of the database that I want to create. So friends.db. It's going to ask me if I want to. I'm going to say yes. And now I'm inside of my database, as you can tell by the SQLite prompt before my typing window. So if I do /schema right now, if you recall, .schema means pull up the schema of my database, which just means which tables are in it, what are the values in those tables, etc. So since I just created this, it doesn't return anything since my database is right now empty. So how do we actually add a table to my database? So this is the syntax for creating a new table. We have the keyword create table, and then we have the table name that we want to give it. Within that, we also will specify the different columns that we want within our table. So you start with the column's name, and then its type, and then any special specifiers you want with it. So we'll show a few examples of that. So let's say, in my case, I want to use create table to make a table named friend with at least 2 columns, ID and name, and then 1 additional attribute. So I'm going to go back over here, and we're going to do create table, and I'm going to call it friend. Okay. And then within that, I want ID to be my first column, and the type of ID is going to be an integer. And then a specifier, one example could be not null. So this just means that within my table friend, I'm not allowing there to be any columns that don't have an ID. Okay, then I also want to store the name. So I'm gonna have that be text. And I'm also gonna say it cannot be null. For a third one, maybe I'll do the age of my friend. And we can have that also be an integer. And say not null. And then, as we talked about with these primary keys, I would like each of my friends to be referred to by the ID, or if I have friends with multiple of the same names, then at least the ID is unique. And so I'm going to specify here that my primary key should be ID. Okay, and then I'll close my parentheses, do a semicolon, and then hopefully now, if I do dot schema again, we'll see that my table now exists with called friend, with the columns ID, name, and age. Okay. So as we can see here, we had these 3 column names, and then each of these have a certain type to it. We have integer, text, integer. You could also do float or a Boolean. And then you have not null, which were the specifiers in this case. Okay. Next, if we want to actually add some values into our table, we can use insert into, which will insert something into the table name that you specify. And then you specify which columns you would like to give the values for, and then the values that you want to insert. So if we go back here, and let's say I insert into my table friend, and I am just going to specify name and age. Something nice about a primary key is that you don't actually have to specify this primary key, and it can count for you. Just like the first person will be primary key ID of 1, then ID of 2, 3, and so on. So I'm going to insert into the table friend with the columns name, age, values. Maybe I have a friend named Alice, and Alice is 25. Okay, seems to have worked. I'm going to do this again, add 2 more friends, maybe Bob, who is 32, and Charlie, who's maybe 42. All right. So now I have 3 entries within my table here. I'll pause here for, you can see a few questions in the chat. Can we change the name of the table without affecting anything? Yes. There is specific, like a keyword that you can use, but we can follow up with that after. Is there a way to set a type of pattern for the ID, such as start with 00x? That's a great question, and I'm sure that there is some way to do that. I don't know off the top of my head, but there are certain ways that you can at least ask for certain kinds of information. Can primary key be a foreign key for another table? Yes. Yeah, so a primary key for one table, maybe my friend's table, can act as a foreign key when I'm using that and relating it to a different table, which we'll see soon. Okay, awesome. Thank you for the questions. So I've inserted 3 friends now into my table. I have Alice, for example. So we have the table friend, the column specified, and then the values in that same order to insert a new value into my table. Let's say I inserted something, but now I want to update it. The update statement looks a bit like this, where we have the keyword update, then the table name, set, and then we specify which value we want to change. We have the name of the column that you want to change, and then its new value. And then where specifies which rows exactly do you want to change. So if I didn't specify a where condition, it would just update that column for every entry in my database, which usually is not very helpful unless that's your target outcome. So let's suppose my friend Alice has turned 26 instead of 25. So I want to update to change her age to 26. So here I might do update my table named friend. And then I'm going to set age equal to 26 now instead of 25. And then I know that I specifically only want to change it for my friend Alice. So I should probably do where name equals Alice. Okay, so once I do that, I can actually do a select query, which we'll talk about in a second. But if I just do select star from friend, then we'll see Alice is now, her age is set to 26 instead of 25. Okay, so again, we have update and then the table name, set a certain column to a new value, and then specify where you want that condition. What rows do you specifically want to change? Okay, and of course we also want to delete things sometimes. Again, this can be a destructive command, so you should be careful when you're working with databases, especially these like delete commands, since it's always a good idea to back up your data, but if you didn't, then that would be gone forever. So let's say I'm no longer friends with maybe Bob. Me and Bob had a falling out, and so I want to delete Bob from my friend table. How might I do that? I'm going to use the delete keyword here. Let me actually clear my terminal just so that we have some more space here. Oops. Friends.db. Okay. So I'm going to delete from my table friend where, so this is where I specify which row do I actually want to delete. I want to delete the row where the name equals Bob. So now if I run select from friend, so I'm just printing out everything in the friend table, we'll see that Bob is no longer in my friend table. All right. So again, we have the table name and then the condition. Okay, any questions about create, insert, update, delete? So these four kinds of commands are all just to create your database and actually insert values, update, and delete those values. What about updating the ID after deleting like Bob? Yeah, so if you notice here, when I deleted Bob, Bob had the ID of 2, which meant his row was gone, including his ID. And so you could just go in and say, now that Bob is gone, I should update, say, my table friend and set ID equal to 2 for my friend whose name is Charlie. And then if I do select from friend again, we'll see that Charlie's ID is now updated. So you can do the same update command also for ID. Okay, so now we'll move to select queries, and we're going to be using a lot of select queries in this week's problem set, but this is very powerful for actually receiving and filtering through all the data that you might have in your databases, especially when you have a very large database. It can be interesting and you can get certain insights from that data. So the very most basic select query that I've been running, we have select star from table name, and this just selects everything. So all the columns, all the rows from the table that I specify. If I wanted to get more specific, then I can also select certain columns. So maybe I only want to see the names, or I only want to see the ages of my friends from a certain table name. And you can also have a where condition to specify maybe I only want to see people above a certain age, or you want to filter it by some condition. You can do so with this syntax. Okay, so with that, we're going to put friends.db away and actually start working on the first part of the problem set for this week, which was songs. So if you follow the instructions on the pset page, you can download the distribution code. And so I went ahead and downloaded that on my code space already. So I'm going to cd into songs. And within songs, I have 8 different SQL files where I'm going to write 8 different select prompts to get certain lists of songs, certain pieces of information from my database. Okay. So songs.db visually is going to look a little bit like this. I definitely will have a table called songs, and within that we have columns ID, name, tempo, duration, and we can see artist underscore ID. And what my artist underscore ID be referring to, that is the ID in the artists table. And so my artists table is going to store for each row a different artist with their name, their birth year, and what label they're assigned to. And so artist ID is a way of relating songs to particular artists. Something David also talked about in lecture was this kind of one-to-one, one-to-many, or many-to-many relationships. And so we could think in this scenario, one song, it seems in the way that we're storing it, can only have one artist ID associated with it. But artists, there could be many songs written by the same artists. And so that might be what we call a one-to-many relationship. Okay, so here are some things that we're going to talk about when it comes to crafting select queries. And first, we're just going to talk about selecting. So let's say in this scenario, I wanted to get all the names from the songs table where the duration of that song is less than 240. It's probably seconds. And so this would then print out all of the names of those songs that fit that condition. So like one by one through the songs table, I'm looking, does this have a duration of less than 240? If it does, then that will be added to the table that I end up printing out. We also have like, which is a helpful keyword for filtering by certain titles that are like a certain thing. And so in this case, let's say I wanted to see, I only want names where there's the word love in the song's title. And so there are a few ways you can do this by using this percent symbol. And this indicates wildcard characters in the relative location of the string. So what that means is that it could match anything where that percent sign is. So this first row in this table, we have where name like percent love, which means that there can be anything before love, but I want my string to end with the word love. So this would match with a song called Somebody to Love, for example. And then the second example, we have love and then the percent sign, so this would be names that have love at the beginning of the title. Finally, if I did a percent sign on both sides, that means I'm going to match with any name that has love anywhere in the title. So for example, I Love Rock and Roll would fit, since I can have any characters before and any characters after love. So this can be helpful if you want to find specific and match certain parts of strings. So within names of songs, maybe names of movies, etc. Okay, so let's get some practice here. So in my first songs SQL query, I want to list all the names of the songs in the database. So pretty simple. I'm going to first open up one.sql, and I'm going to write my query here. So I know that I want to get all the names from the songs. So this is going to be a select query. What column should I be selecting for? Yeah, so I want the names from the database songs, or the table songs. And that should be good. So if I run, oops, what's it called? Okay. So I'm going to open up my songs.db database that has already been created, and let me just run this query. So this is going to get the name of all of the songs. So you can see we have I think this is the top 100 songs in 2018 we have. So it looks like that worked. We printed out all the names. So it's great. All right. Next we have ordering. So we can print out and select a chunk of entries, like a number of rows, but perhaps we want that to be ordered in a certain way by some certain column or metric. So one example of this could be we have select star, which means just all of the columns from songs where the tempo is greater than 100. And then we're also applying this order by keyword. So order by will then have a column specified. So which column do you want to order this by? And then you can also specify if you want it to be ordered descending or ascending. So in this case, what I'm actually doing here is I'm getting all of the songs from the table songs where the tempo is greater than 100, and it's going to give me all of those songs from highest tempo to the lowest tempo. If I didn't include descending, that keyword, it would be ascending by default. So I could also specify ASC to specify that I want the tempo to be ordered in ascending order, so from lowest to highest. But if you don't include that keyword, it does that by default, so no need to include it. Okay, so based on that, let's do something pretty similar here and list the names of all the songs in increasing order of tempo. Okay, so I'm gonna open up 2.sql here. And here we're gonna do, select the name from songs. And we want this to be in increasing order by tempo. So how would I do that? Feel free to write that last part in the chat. Yeah, so I have order by, great. And then after order by, I want to specify the column that I want to order my results by. So which column? Tempo, yeah, exactly. So I'm going to order this by tempo, and since I want this in increasing order of tempo, I could include ascending here. I also don't have to since it's ascending by default. So now if I run this in my database, we see we have my songs, same number of songs, but now it's ordered by tempo. If I wanted to actually see the tempo, I could add name comma tempo here so that I can see multiple columns. And if I run that, we can see here, we go from the slowest or lowest tempo up to the highest tempo. Okay, awesome. Okay, next we're going to talk about limiting, which is another thing we can do with our select queries. If I only want a certain number of rows to show up, I can use this limit keyword to say I only want the first one within this list, or the first 5, or however you want it. So this is the query we saw earlier where we're getting all of the songs where the tempo is greater than 100, and then we're ordering it by tempo. So without the limit, this would just print all of the songs that have tempo greater than 100, but starting from the slowest tempo to the highest, or fastest. If I did limit 1, then that means it would only print out that first row. So the slowest song that has a tempo greater than 100. Okay, so those were a lot of keywords, but we'll just review them over here. So we had the star, which selects all columns. For example, if we were looking at a database of courses, then you could use star, select star from courses to return every column and every row. Like checks if a value is sort of like a provided string, and you can use that percentage sign to serve as a placeholder. So for example here, if I wanted only the course codes that started with CS, then I could do select code from courses where code like CS percentage sign. Then we can do order by, and you specify the column name to order by ascending or descending. This also works for text. So if I had select name from people, order by name, then this is going to order all of these names in alphabetical order. We also have limit, which limits the number of results to a certain number that you specify. Any questions here about any of these keywords? And SQL also supports a number of other keywords, but these are the ones that we're going to focus on today. All right. Okay, so this next one here, we're going to list the names of the top 5 longest songs in decreasing order of length. So I'm going to open up 3. Okay, so as always, I'm going to select, but then what column should I be selecting for here? If I want the names of the top 5 longest songs. So what comes after the select is the name of the column that I want to end up printing. Yeah, so name. So I want to select the name column from the songs database. And then here we know that we want to go in descending order of length. So what might that look like? I'll definitely have order by, but what column should I order this by? And for this, it might actually be helpful if I do .schema here and I look at my songs table. So I'm looking for the length of my song, and I can see these are the columns that exist within my songs database or table. And so it seems like duration in seconds will give me that length. Great. And then I do also want this to be descending. So I want it to go from the longest to the shortest. Okay. And then finally, I also only wanted to list the top 5 songs. So I can limit my output to just 5. Okay, so let's see how this works. If I copy this into here, it seems like we've got 5 songs. And let me maybe add the duration here just to double check that these are indeed the long songs. Okay, so that seems pretty long. If I didn't have the limit and I just did this, then we can see it seems like these are the shortest songs here. And it does seem like these 5 that were printed out here are the longest 5 songs. Okay. Any questions here about selecting, ordering, limiting? All right. Move on to this next one, for.sql. We're gonna list the names of any songs that have the danceability, energy, and valence all greater than 0.75. So if we look up here with our schema, we can see that we have some of these columns called danceability, energy, and valence, which are all this type real, which is just another kind of number. And so let's open up code for.sql. And we're going to want to select some names from songs. And then how might we filter these songs to only show those that have a danceability, energy, and valence greater than 0.75? Yeah, so we have this where keyword where we have now specifying some condition that we're going to filter by. So I know that for the first thing, I want the column danceability to be greater than 0.75. And then I also have 2 more conditions here. So I can use my and keyword to combine these conditions. So I want to look for this to be true and energy greater than 0.5. This should also be true, and valence should be greater than 0.5. What would happen here if instead of ands I change this to ors? Would this print out more songs, less songs? What would happen? Yeah, so this would print out more songs than if I had an and condition, since if only one of these conditions are true, then it will add it to the results of my select. So if I change this back to and I run it here, it seems like we only have 5 songs that fulfilled all of these conditions. If I only did ors, we only have to fulfill one of these conditions. And it seems like we have a lot more songs that fulfill at least one of these conditions. Great. All right. Okay, we're gonna move on here to a few more things. So we have aggregating. So this is when I want to get a certain piece of information from the output of my select, not just the rows. And so one keyword we can use is count, which rather than printing out all of my entries, all of my rows, it's actually going to just give me the count of how many entries would have been printed. So in this case, select count bracket star. This means for the columns star. So it doesn't really matter which column I put here. I could put name, I could put tempo, but since it doesn't matter what goes into count, it's best practice to use the star here. So we count the number of rows that pop out from songs where the tempo is greater than 100. So this would give me the number of songs that have a tempo greater than 100. We also have average, which is another keyword here, where if you pass in a column, hopefully a number, so in this case tempo, it will give me the average value of the rows that would have been printed. So I could also add a where condition here. Maybe I only want the tempo of songs by a certain artist. I can do that as well using average. A few more of these keywords here. We have average and count, which we just talked about. We also have distinct, which if I pass in, say, name, it will only return distinct results. So it won't return any duplicates if there are names of songs that are the same. We also have intersect, which given two queries will only return results that are common to both queries. Okay. So using these new keywords, let's find the average energy of all of the songs. Okay, so I'm going to open up now 5. And we want to get the average energy. So what would I put here after the select? Yes, average here. And then the column that we're specifying is energy, since that is the column that I want the average of. From my table songs, and I'm not going to add any conditions here. I just want the average of all of the songs. Okay. So now we can see it gives me a table that specifies this is average of the energy column, and the average is 0.65906. Cool. Okay. Pause here. Any questions about aggregating and these keywords? All right. Okay, so now we'll move on. Oh, can we do this? Okay, I'm not sure what that question means, but I'll come back to it at the end here. Okay. Making the exercises with that count changes the quantity of the results. So I'm not sure if this is what you're getting at, but if I did count here, we can see that, oops, rather than getting, say, 100 songs like written out in 100 rows, I just get one row with that number count. So using these aggregation keywords will change the number of results that are given to us. Yeah. Okay. Okay, let's move on to how might we reference data across tables, right? So we have some interesting, helpful things we can do within one table. And in our case here, we had songs, but then we also have some information about these artists, like the names, that we haven't really been able to get with just the songs table. Since this only gives us artist ID, which maybe is not that meaningful to me if I don't know whose artist ID belongs to who. So how might we actually use the data across these tables? There are two ways that you can do this. We have selects, nested selects to be specific, and you can join tables. So let's first talk about nested selects here. So as we remember, this artist ID column is the ID of each artist in the artists table. And so it's referencing that value. And so those things are the same. So if I wanted to query for all the songs by the artist named Oh Wonder, what information would I need here? I know that I want the songs by Oh Wonder, which means that it's probably good for me to know what the ID of Oh Wonder is. Yeah. So once I know that Oh Wonder, this artist, has the ID of 45, then I can use that when querying songs to only look for the songs that have the artist ID of 45. So one way of doing this, we can see laid out here, is that I first, on this inner select here, am selecting ID from artists where name equals Oh Wonder. So that's going to give me the ID of the artist named Oh Wonder. Once I have that, then it's like I can plug that value. So this returns 45, like we saw here. I can plug that in now into my outer select, which is basically now just going to be running something like this, where I have select star, so all of the songs where the artist ID equals 45. So this is good because when I write it like this nested select, I don't actually have to worry about what the ID is of Oh Wonder. I could just run that first SQL query and then hard code, say 45, into the outer SQL query, but that adds some extra steps for me, the programmer, and it also adds in that opportunity of maybe typing something wrong or just copying over something wrong. So doing it this way allows me to only have to focus on the information I do know, so the name being Oh Wonder, and then letting the database do the rest. Okay. Another example here, we have query for all of the songs by artists born after 1980. So there could very well be more than one artist that's born after 1980. So in this case, what information do I need? Yeah, so I need to know the birth year of my artists. And once I know which artists are born after 1980, the IDs of those artists are going to be important for me to know. So a bit like what we just saw, but slightly different here. That inner select query, select ID from artists where birth year is greater than 1980, this might actually return to me not just one artist, but 2, 3, 4, many artists. And then this outer select is now doing select star from songs where ID is in this list. So in our previous example, we did ID equals because I was just looking for the ID of one artist. And so I wanted the songs where the artist ID was equal to that artist ID. In this case, it's slightly different because this inner select query might actually return to me more than one row, more than one artist that is born after 1980. So we're actually going to want to check if the ID is in this list, not just equal to the first one in the list. So if I run that inner query, I can see that both of these artists here are born after 1980. And so we would sort of get a list like so. And then we're just looking to see whether a song's ID, or artist ID, I should say, is in this list of artist IDs. Okay, and then it would give us these two songs. So just to recap here, we use in instead of the equal sign when you're checking if something is in a list, rather than just equal to a single value. Okay, another way of doing this here is using joins. But I'll pause to see if anyone has any questions about nested selects, as I know that can be confusing to learn at first. All right, okay. So let's talk about joins. So as we know, artist ID and ID line up. Those two pieces of information, if I see 23 in songs, is gonna line up with the artist who with the ID of 23. And so what I could actually do here is physically line these entries up like so. And now I have this big mega table that includes not only the songs, but also the artists of each of those songs. So what does this actually look like in SQL? We would write a statement a bit like this, where we have select star, so all of the columns from songs, and then that songs table, we want to join it with the artists table. And then this on keyword tells us which IDs across these two tables are we joining on, which of them are the same. So in this case, we have songs.artistID. So this is just a way of saying from the songs table, the artist ID is equal to, in the artists table, the ID column. So we just have this syntax where we're specifying the table dot and then the column name. So once we do that, we have our big table. And then we can run a condition just like so, where we have where artist's name equals oh wonder. So we do have to specify now when we use a column like name, we can't just use name itself, as there is also name in songs, so we have to specify from the artist's table, look for the name equal to oh wonder. Okay. Any questions about joins? Okay. I will note that joins are typically going to be a bit slower than nested selects, but it does depend on the situation that you're using it in. So for some of the earlier examples we did, where let's say I only wanted the artist's names oh wonder, it might be faster if I just use a nested select, since that is just querying for that artist's ID and getting those songs associated. Join, on the other hand, is going to actually take those two tables together and join up every single row with each other, and so that's going to take a lot more time and is not necessarily going to be as useful if you don't need all of that information. The join gives us duplicates. Yeah, so the join, if I went here, you could imagine if, say, I had multiple songs by Oh Wonder, then I could have another songs row here, and it would have the same information from the artists table with Oh Wonder, their birth year, and what label they're signed to. Okay, and you are able to join 3 tables together. It would look a bit similar here where you have, after you've joined on this value, you can join on another table. Okay. Yes, and this is the only way of using join. There aren't different types. Okay, so let's get some practice here with nested selects and joins. So for 6.SQL, we want to list the names of the songs that are by Post Malone. So Post Malone is some artist. I'm going to go to 6. And so I know that I want the names of these songs. So I'm going to select name from songs. But then I know that I want only songs that are by this artist. And so what column might I be looking for to filter by in songs? Yeah, so I'm going to be paying attention to this artist ID. I only want songs where the artist ID is equal to the ID of whatever Post Malone is, right? So I don't know that information right now, but I can do a nested select here to get that information for me. So how do I get the ID of Post Malone? Do select ID, this time from artists, so the artists table. And then what is my where condition here? Yeah, name equals, and then the name of my artist. Okay, and then my semicolon goes at the end of my statement here. So let me also include, or actually, yeah, just name. If I run this query here, we'll see 6 songs that are all by Post Malone. We can also pretty easily do this by joining, but again, I think that, at least in this case, so nested selects are going to be more efficient. Okay, this next one here, we're finding the average energy of songs that are by Drake. So I'll do 7. And so how would I go about getting the average energy here? Yeah, so I'm going to use my keyword average here, AVG, and then the column that I want. So energy from songs. And then I only want songs that are by Drake. So sort of like what we just did here with Post Malone, I'm going to do where artist ID is equal to, and then I want this to be whatever Drake's artist ID is. Right? So I'll do something similar where I'm going to select ID from artists where the name of that artist equals Drake. Okay, so then hopefully that should give me the average energy of all the songs where the artist ID is equal to Drake's artist ID. Okay. And then it seems like we got 0.599. Great. Okay, last one. We have list the names of the songs that feature other artists. So for this, we can make the assumption that any song that features another artist is going to include that feat keyword. So let me open up 8. And so I'm just going to make the assumption that the song is going to include here feat, and that's how I'm going to know if it features someone else. So what column should I be selecting for? Yeah, name. So name of the songs from songs. And then how am I going to build this conditional where I want the title or the name of the song to include this. Yeah, so I can use the like keyword here. And then here I want to build this string that's going to match a name that has feat in it. So yeah, you can use this percentage sign, and we can do feat, and then another percentage sign. If I only had one percentage sign like this, what would happen? What would this query print out? Yeah, so this would give me only songs that began with feat dot. But it's probably likely that not a lot of them start with that. So including this at the beginning then matches for anything that comes before the featuring. So if I run this, what do we have here? I think we should use single quotes here. Okay. Oh, I see. What did I do wrong here? Someone says equals. Not quite. Yeah, missing field in where I forgot to specify that I actually want the name to be like feat. Otherwise, it doesn't know which column I'm trying to match it up with. Awesome. So now that if I put that in, it seems indeed we do have all of the songs here that are featuring another artist. Okay, awesome. Any questions about these last 3 exercises we did, or about joining and nested selects? Someone's asking why you would use or, oh, I see. Yeah, it's a good question. So the single quote versus the double quotes, it's really just a styling thing. So it depends on the standards that you're using, but as long as it's consistent within your code, so you're not using single quotes here and double quotes in another place, then that's okay. But yeah, it's a style convention. Good question. So if I change this back to double quotes, I think it should still work as expected here. Yeah. Okay. Well then with that, that is the end of SQL week, section 7. I hope you join us next week, same time. And until then, I hope you have a good day.